Well, let's be honest. The large dataset can feel like the most intimidating part in A-level maths exam. You are given this huge spreadsheet and expected to what? Memorize it all? Well, the good news is you are not expected to memorize them all. In this video, we are going to demystify the large dataset once and for all. I'll show you that it's not about memory, it's about specific way of thinking. We'll cover the big picture and then the 5 simple patterns that appear in the exam papers from year 2018 to year 2024. And by the end of this guide, you will see the large dataset not as a threat, but hopefully as an opportunity to secure those couple of marks in the paper. First, let's talk about the big picture. The large dataset isn't about memorizing a spreadsheet, it is about testing your ability to think like a data scientist. This means 3 things. 1. Can you interpret the data? This is about turning a number into a story. For example, knowing that a mean temperature of 25 degrees Celsius is normal for Jacksonville in summer, but impossible for the UK town in October. 2. Can you critique a statistical model? This is about understanding the theory. You need to know why a perfect model, like a normal distribution, might be a poor fit for real-world weather data, which is often skewed or unpredictable. And 3. Do you know the process? This is about practical side of statistics. Can you identify problems in raw data, like non-numerical values, and explain how to clean them for analysis? If you can master these 3 ways of thinking, you'll be set for any question in the large dataset that they throw at you. Okay, that's a bit abstract, right? Let's dive into the 5 key patterns that I spent quite some time analyzing through the past papers from 2018 to 2024. Pattern number 1. Know your data. You need a solid general knowledge of the locations, variables, and units. First, the locations in the UK. You have Leeming in the north, which is generally cooler, then Heathrow, Herne, and Camborne in the south. For the international locations, remember that Perth is in Australia, so its seasons are kind of like reversed to the UK. Jacksonville is in Florida, and it is much warmer. And Beijing is a continental climate with a more extreme hot and cold seasons. Next, the variables and their units. Make sure you know these by heart. Temperature is in degrees Celsius, rainfall is in millimeters, and you absolutely must remember that in quotation TR means a trace amount, sunshine is in hours, wind speed is in knots, and cloud cover is in octas, which are eighths of the sky. Let's see how this is tested. Here is the 2019 paper. It gives a summary of statistics for the daily mean air temperature in Beijing. It highlighted that the lowest temperatures, which are around 8 degrees Celsius, were outliers. The question asked, from which month are these outliers likely to have come? Well, to answer this question, you use your contextual knowledge. The data is from May to October. Beijing is in the northern hemisphere, so it gets colder towards the end of the year. The lowest temperatures must have come from the latest month in the dataset, which is October. Simple as that. Now, pattern number 2. Know your models. You will frequently be asked to critique a statistical model. This means checking if the model's assumptions hold true in the real world. Here are the key models to know. Normal distribution. This model is symmetrical, so it's a bad fit for skewed data like rainfall or wind speed, which can't be negative. Binomial distribution. This requires independent trials. This is its biggest weakness for weather data, because the weather on one day is rarely independent of the next. And a discrete uniform distribution. It assumes every outcome is equally likely. This is often a poor fit for things like cloud cover, where a perfectly clear or fully overcast day might be more or less common than a partly cloudy day. Let's look at a classic example from June 2018 paper. Helen models cloud cover using a discrete uniform distribution. The real data shows that the proportion of days with less than 50% cloud cover was 0.315. The question asks you to comment on the model's suitability. First, you calculate the model's prediction. Cloud cover is measured in eighths, so less than 50% means 0, 1, 2, or 3 octaves. In a uniform distribution, on the integers 0 to 8, there are 9 outcomes actually. So the model's probability is 4 divided by 9, which is about 0.444. Then you compare. The model predicts 0.444, but the reality was 0.315. Since these values are not very close, you conclude that the model is not very suitable. Pattern 3. Know your methods. This pattern is all about practical steps of handling data. There are 2 key cleaning steps you must know. First, how to handle the TR for rainfall. It stands for a trace amount, of course, which is not a number. For calculations, you have to replace it with a numerical value, like 0.025, which is the midpoint of the interval it represents. Second, how to handle grouped data. If you have a class interval like 2 to 4 millimeters of rain, you must use the midpoint, which is 3 in this case, for all calculations of the mean or standard deviation. Let's look at the June 2023 paper. The question asked how rainfall data, which included the TR values and grouped classes, would need to be cleaned before calculating the mean. Your answer should state 2 clear steps. First, replace the TR values with a number like 0.025. Second, use the midpoint of each class for the grouped data. Pattern 4. Know your world. This is about applying external knowledge, usually basic geography or meteorology, to interpret the data. The most famous example of this was in October 2021 paper. It gave you the pressure readings for Heathrow, Herne, and Lucas, and stated that wind circulates clockwise around a high pressure system. Heathrow had the highest pressure, making it the center or near the center of the system. The question asks you to match the wind directions, west, northeast, and east, to the correct locations. To solve this, you need a mental map of the UK. Lucas is the north of Heathrow, quite further north actually. Herne is to the southwest. Applying the clockwise rule, for Lucas, which is north of the high pressure center, the wind must come from the west. For Herne, which is to the southwest, the wind must come from the northeast. That leaves the east wind for Heathrow. This question perfectly combines data interpretation with simple scientific knowledge. Pattern 5. Know your limitations. This final pattern tests your understanding of sampling bias. The most common scenario is being given data from a limited period, like just the summer months, and being asked to comment on using it to estimate values of the whole year. There are 2 parts to your answer. First, you must state why the sample is not representative. Second, you must predict the direction of the bias. Will the estimate be too high or too low? The June 2023 paper again asked about using May to October rainfall data to estimate the annual mean for Liming. Here's how you can answer it. First, why is it unsuitable? The sample is not representative because it omits the autumn and winter months. Second, what's the effect? The UK's winter months are generally wetter than in the summer months. By leaving them out, the sample is missing the highest rainfall values. Therefore, the estimate of the mean will be an underestimate of the true annual mean. And that's it. By understanding these 5 patterns, knowing your data, critiquing models, cleaning the mess, applying world knowledge, and spotting limitations, you can confidently tackle any large dataset question that comes in your way. I really thank you that you have watched this far, and I would encourage you to go check the other videos relevant to this examination. Please help support me by like or subscribe or do both if you love me. See you in there.